Now to convert the user finder to a class-based component, I will again import component from React and then define a class named user finder, which extends component, of course. Now in here we need a constructor because we got some state which should be initialized by setting this state to an object. Now here I actually got two state slices, the entered search term and then the list of users, and therefore I'll add my filtered users here and set that equal to dummy users, and then add my search term and set this equal to an empty string initially. Next, we got a function here, the search change handler, which I'll implement as a method in the user finder class, because that is then the function, the method that should be executed to update the state, at least a part of the state. It should update that search term. Now we get the event object here because this is bound to the change event on the input, and we then use the event object to read the value entered by the user, and therefore we can expect this event object here as well to then set our state, important, here always to an object, which is then merged by React, and update the search term part of that state to event target value. And only that part. Again, it will be merged, so the filtered users won't be lost. Of course, we also need to add a render method where we should return our JSX code. So I'll grab this return statement and add this here as well. In here, I should point at this search change handler, and also, to ensure that the this keyword works correctly in the method, bind this as explained in the last lectures. And here for the filtered users, we should refer to this.state.filtered users. And with that, we transformed this component, at least almost. One crucial part is missing, and that would be the useEffect function here, which we can't use in a class-based component. Now we could derive our filtered users and set them in our state update here in the search change handler. That would be possible. But I want to show you how these lifecycle methods work, and therefore I'll use an alternative approach. We can add component did update here, and this method will be called automatically by React whenever this component is re-evaluated because its state changed, for example. So therefore in here, we could set our new state for the filtered users. So here we can copy this logic from the user finder functional component and call this setState to set the filtered users equal to dummy users filter and so on. However, if we would do it like this, we would create an infinite loop, because component did update is now executed every time this component changed. When we set the state, the component will change. So then this will execute again, and it will change the state again, and it will execute again. You get my point. This would be an infinite loop. Therefore, what we need to do is we need to check whether the state we're interested in changed. In this case, if the search term changed. For that, component did update receives two arguments which help us: the previous props and the previous state. So the last props and state snapshot before the current component update. And with that, we can check if privProps search term was different than the current search term. So this state search term. Only if it is different, so only if the search term changed, I want to execute this logic. If something else changed, like for example the filtered users, which we are updating here by calling setState, this method component did update will run again, but we won't make it into this if block. So we won't update the state again, and we won't have an infinite loop therefore. Here, by the way, it should also be this state search term. And now with that, we replace useEffect with component did update. This also shows you how nice useEffect is. It's very short, and by specifying the dependencies here, we don't have to add an if check inside of it. We need to add an if check here for component did update to prevent an infinite loop, but we don't need to do this with useEffect because we specified search term as a dependency. So automatically, this effect function will only be executed by React if that dependency changed. And other changes and other reasons for this component to re-render are ignored for this effect because of this dependencies array. Now, one thing I just noticed, by the way, of course, I don't want to compare pref props, but pref state. The previous state search term should be compared. If you would be updating based on prop changes, so you got some new prop values and you wanna, and the component therefore updates, then you could compare previous props to current props, but here it's the state change which matters to us, the state change inside of this component, and hence we compare our previous state, a specific slice of that state, with the current state and that specific slice of that state. Now we should also add super in the constructor, by the way, before we forget this. And now we transformed this component, and we can hence remove user finder in the functional form or simply comment it out. And now if I go back, this again works as before, but now with class-based components and component did update. And as I mentioned before in this module, it's a different mental model. When you work with these lifecycle methods, you primarily think about when will this method be called, which is the case when the component updates. And then you might need to add if checks to restrict your logic in there. With useEffect, you don't care about whether the component is rendered for the first time or if it updated or whatever. You care about the fact that search term changed. And whenever that changes, you run this logic, which is a very simple mental model in a positive way. Nonetheless, you could use component did update instead, as you saw here. Now, besides that, we also got other lifecycle methods, most importantly, component did mount and component will unmount. Now let me show you these lifecycle methods as well. Let's say our dummy users are loaded from a server, from a database. So we're sending an HTTP request. We're not doing that here, but let's imagine we're doing that. So initially, filtered users might be an empty array. Then, when the component is rendered for the first time, we want to send a request to the server. Hence, we can't use component did update in this scenario because I don't want to fetch the users over and over again. You might need to do that in other apps, but not in this imaginary example. Instead, we want to fetch the users when this component is rendered for the first time, and that is something we would typically do with component did mount. You add component did mount like that, and then in there you could send your HTTP request and handle all of that. And eventually you would update your state and set your state, in this case, to set filtered users to dummy users, which might have been fetched from some server. Again, it's just a dummy example here. That's what you could do. We don't need an if check here because component did mount will only run once when the component initially was rendered for the first time. If it then is updated thereafter, component did mount will not execute, instead component did update will execute. So therefore that's how we could write this, and if we do, we essentially got the same result as before, but now we're loading this when the component is mounted. The equivalent to that in the functional component world would be to call useEffect with no dependencies, or even with dependencies, it would execute this function when the component is mounted for the first time, because it treats the dependency as to have changed if we had no dependency before, because the component wasn't rendered, and now it is rendered, and therefore we do have this dependency. So the useEffect function will also always execute when the component is initially mounted. Now, last but not least, we have component will unmount, and I can show this method in the user component, because the list of users is rendered conditionally, so it is actually removed if I click hide users. Therefore, in the user component, which is also a class-based component, I can add component will unmount, and in there I'll just console log user will unmount. And if we now save this and go back and open the developer tools here, like this, if I click hide users, you see user will unmount 3 times. Why 3 times? Because we used the user component 3 times. We rendered 3 users in the end, and all 3 instances of that component were removed, and all these lifecycle methods run for every component instance, of course, just like useEffect and state work for every component instance standalone. And these are the lifecycle methods. It's a different mental model, but in the end, with it, you can of course achieve the same as you can with these React hooks, with useEffect and so on. It just is a bit more code, and it could be the more difficult mental model. Now, what about context and class-based components? Well, the first important takeaway is that you can still define it and provide it as you learned it. You define it by calling create context, maybe with some initial value, and you then provide it by using the provider component, which is part of that created context object. And then you can pass a value to that. And here it's actually a static value which never changes, but it also may change with state updates. And that all doesn't change. Only the way you update state, of course, changes if you use a class-based component, as explained over the last lectures. As a side note, if you want to follow along, attached you find the updated app component and this user's context.js file, which you can add into a newly created store folder. But back to that. Here we provide as we learned it. The only part which changes when you're working with context is related to how you use it in your class-based components. Now, I haven't added any code for using context up until now, so therefore let's go to the user finder and think about how we could add it there. There, let's say, I no longer want to work with the dummy users defined in this file. I no longer want to get my data from there, but instead I want to get my data from context, because it's managed application-wide. If this would be a functional component, we would of course use the use context hook for that. That's what we would do. But this is not an option here in the class-based component because we can't use hooks there. Instead, here we got 2 ways of using context. One approach was shown to you earlier in the course already. The context consumer component can be used in both functional and class-based components. So in your render method, you could import the user's context, so add it here, and of course import it from the user's context file, and then simply add that consumer or access this consumer component and then use it as shown to you earlier in the course. Since this is used in JSX only, it works in both functional and class-based components. But the use reducer hook is used so that we don't have to use this consumer component. So what's the equivalent to this? There is no perfect equivalent. I will say that right away. With use context, you can listen to multiple contexts in one and the same component by calling use context multiple times and pointing at different contexts. This will not be possible with class-based components, because there you can only connect a class-based component to one context. And you do that by adding a static property, by adding the static keyword here, and then adding the property named context type, written like this. And then you assign a value of user's context here. With that, you're telling React, hey, this component should have access to the user's context. But you can only set the static context type property once. So if there are two contexts which should be connected to one and the same component, this would simply not be an option. You would have to find some other workaround, like wrapping it in another component or anything like that. With that set, however, you can then simply access this context users in this case, in all the places where you need access to the users. And with that, it will again work as before, as you can tell, but now with context. So it is also quite straightforward to use, but a bit less flexible than in the functional component world. Of course, you will not always need more than one context per component. Often one context is enough, but if you do need more contexts connected to one component, then this restriction can of course hurt.